Okay, we pick back up with number 12, and so we can, because that's addition, we can say natural log of x plus, first thing we want to take care of is this coefficient and rewrite it as an exponent. So now we're able to, once the coefficients are both 1 and we're left with the natural log, and the natural log, we can say the natural log, natural log of xy to the 7th. Alright, well, number 13, we can see that the first thing we want to do is probably distribute this out so that it's in both terms. So that would just give us 1/6 log, actually, that's a base 4. 1/6. Okay, we see that the log base 4 is the same and the log base 4 is the same, so we know we're going to be able to condense these further, but we want to make our coefficients 1. So what can we do about this 1/6? Use the power rule to move it as an exponent. Good. So basically this becomes log base 4 of x to the 1/6 power plus log base 4 of y to the 1/6 power. And now looking at that, we can rewrite using multiplication. So this would give us log base 4 of x to the 1/6 times y to the 1/6. Okay, how else can we write that to simplify it a little bit further? What's x to the 1/6 power? The 6th root of x, and then so you could do, good, we can say the 6th root of xy. Okay, 14 looks pretty long. It's 1, 2, 3, 4 terms, and some of our arguments look a little more complicated than the simple ones above, but log base 10, log base 10, log base 10, log base known base of 10. They're all consistent. All the coefficients are 1, coefficient 1, coefficient 1, 1, 1. So we're ready to use our rules. So we're going to start with log known base 10. Start with the first argument. Now, from the first argument to the next argument, it's addition. So what are we going to do with those two? Multiply. Okay, but you can see the next one is subtraction. So that one's going to require division. So we use our quotient rule. And then the following one is division. So, I mean subtraction. So we use our quotient rule. Okay, so let's just make sure you're comfortable with that. Alright, now we can do some simplifying in the top because it told me to evaluate it possible. I can use the difference of perfect squares right here, and that would factor to give me x plus 14, x minus 14. If you're not sure, look up the difference of perfect squares to factor that out. So now what do you see? Yes, this x minus 14 and this x minus 14 can cancel, so we would be left with log. In the numerator, we get x times x plus 14, and in the denominator, we just have 7. We don't have to distribute the x, we're just leaving it in a condensed form, although it's not necessarily wrong if you would have x squared plus 14, but then you'll have exponents back in it. So you see what I'm saying? This is probably going to be our simplest condensed. One question was, what happened if they have a different base? So like log base 4 of x plus log base 3 of y. You cannot use properties to simplify this any further because the properties say that they have the same base. That's what allows us to use the rules. So basically this is simplified. We can only use our properties when they have, when for example it would be log base 4 and log base 4, or the same base. here are a couple of extra examples for you to pause and practice. I'll give you a few minutes and then I'm just going to give the solutions. Okay, first we use our power rule. Then after that, I decided to rewrite 25 as 5 squared, and then we use this rule, and then afterwards we simplified to that. This is a condensed one to practice. Okay, next we have our change of base, and so an example for this is going to be if you have log base 412. So say we have this and they ask us to evaluate this, and we can use our calculator to do so. So practice in your calculator. This can be rewritten as log base 12 divide by log of 4. Remember, in a calculator there's a known base 10, so it's going to evaluate that. Log of 12 divide by log of 4, and approximately 1.792. Okay, try the next example. Calculate this using change of base. So in our calculator, we would say log 140 divided by log of 5, approximately 3.07. So change of base is a very simple process, so we can now put this in our calculator and calculate those.